Hi, I'm Hatice from Akkok, Turkey, and thank you for having us in Young SDG Global Summit today. Here is the name of our project, and I would like to first introduce our team. We we attended this project as Akkok corporate, but we wanted to find a solution to Akkok company, which is a group company of Akkok, and we in the team have all different backgrounds. Like I'm a physicist, material scientist, financial departments, and so on. And so what we as I said, we wanted to find a solution to Akkok, our group company, and we are working in Akkok in enamel department, and we wanted to find a solution for the enamel department because the total turnover in 2020 was the highest for the enamel department apart from the other departments. And what we did, we created the enamel production process before we find the project. So we know how our production process, and we made a project timeline. We made mentor meetings starting from April. We did a project design. We started to think how to find a solution or how to find a project which will have a 10x impact both on business and social side. We did individual meetings with our directors for supply chain, for production, human resources, and so on. And then we found our solution. And when we go back to our slide, the bottleneck of enamel production was all production companies, raw material supply and the energy. And in raw material supply, we found that the costs are 87% of the costs belongs to raw material supply. So we wanted to work on that item. Here in this graph, we present the yearly basis, the total cost of Akkok's production, including raw materials and energy. As you can see, from 2016 to 2020, the total cost is always fed by raw material and utility. So here I present you what raw material, lithium and cobalt, is the most expensive ones. And here in this graph, the yearly basis metric ton price of lithium. And now this graph is also not anymore valid because the lithium price is now somewhere here, even though we are in 2021. And if we see what are the end-use industries lithium consumption is, there are batteries. As everyone knows, electrical vehicles are coming, so they need batteries. And glass is here as green. And here it summarizes the usage of lithium-ion batteries. The raw material market size for lithium-ion batteries in 2020 is 150, whereas for glass ceramics, 27. And as you can see, in 5 years, there will be a factor 3 of increase in lithium-ion batteries. So the demand will increase. So we have to secure our lithium and cobalt supply chain or raw material procurement. So in direct model, as I showed you in the previous slide, there will be an increase in lithium and cobalt price, and there will be a supply shortage risk along with it, and this will show up as an increase in energy costs and usage. So we have to sell our products more expensive. So our solution to that problem, which will have benefits for business and society, is we know that there are electrical batteries and electrical cars, and there are lithium-ion batteries, and we would like to use the recycled and recovered lithium and cobalt, like metal oxides, precious metals from the recovered batteries, as a precursor as a raw material for our precursor glass ceramic. Here, this is an image of a glass raw material for glass ceramic coating application, which is also named as enamel. Then we will be able to produce sustainable raw materials, and our sustainable economic growth model will be valid. With this, we aim to reach responsible consumption and production. And from direct model to circular model, we are having an alternative raw material usage for increase in supply security. We will have an increase in recycled raw material and waste usage in production, and there will be no additional energy cost and usage because we did the proof of concept that everything stays the same. And then we will be able to produce sustainable product for the target companies. Target companies means companies which are sensitive in sustainability. And our go-to-market plan is here, as you can see. Step 1, we will interview with target customers. In step 2, we will develop new business opportunities with battery recycling companies and secure contracts. And in step 3, we will do marketing activities regarding these issues. And at the last step, we would like to include the government, like Ministry of Trade and Ministry of Environment and Urbanization. We did a competitive analysis, SWOT analysis too, and we know our strengths and our weaknesses. We found what the threats could be, and this could be inability to collect enough batteries and regulation adaptation and legal issues, because everything you produce has to have some standards, and the regulations are really important. And we found the opportunities that we will have an increased commercial competition. We will secure the production, and the products will be having an added value. With this slide, I would like to thank you, and I'd like to present our highlights. We applied for a patent throughout this project, and in 2 days, we will be submitting a Horizon Europe project for funding. And thank you so much. Should I stop sharing, or?
Yes,
because please. I cannot see you.
We will move to the questions with Kim, Manda, and Nazim. Who would like to go first?
Kim, do you want to go first?
Sending it around.
I don't know.
So thank you so much for sharing that presentation very well, and also giving us good insights. So how far are you from realization? Because you had a very early in the presentation, you had a process plan, but
yes,
yeah. So
okay, we contacted the battery recycling companies, and we purchased some sample, like black mass they call, when you recycle the battery, and we did a proof of concept for 1 kg. So in the process, we are in the laboratory scale now, but we would like to upscale, and we would like to do life cycle assessment for the project. So that's
maybe to follow up on your question, Kim. So the 1 kg test that you did that work? Was it successful in achieving the results you wanted?
I can show you also the results, but I didn't have time. So we had 2 different precursors. We prepared 2 different precursors, and we compared with our standard sample, with our standard glass ceramic coating material. And if you compare the glossiness, the mechanical properties, chemical resistance, and so on, they were all comparable. And also in lab, not only visualization, but also characterization, such as scanning electron microscopy to characterize the microstructure and the crystallization of the products, both products. but of course, all were in lab scale, and we would like to do it now in upscale the process.
Nadim?
Is there any thank you, Manda. Is there any reference or any? I mean, you presented financial data, but for me, environmental data related to whether you can actually scale up operations. If you can give us any idea of what is the projected impact from that perspective.
Okay. For example, now in the project we would like to do in which we applied for funding, we would like to have the lithium-ion batteries. When you have them, the recycled, they are black mass, and they have like 50% of it graphite, which you have to get rid of. And if you do burning out, then you will end up with lots of CO2 emission and fluorine gas and so on. But we applied for patent, and also in the project, what we would like to do is we do we don't do pyrometallurgy, but we do hydrometallurgy. So there is no burning. You just do the flotation, and you have both graphite and lithium cobalt at the same time. But there will be no increase in energy in terms of like in our case where we do production. We have all the oxides and then do a firing or do melting, and there is a melting temperature, and we check the melting temperature in case what is the melting temperature now, what will be the melting temperature when we use the recycled material. There is no change in the melting temperature, but for real CO2 emissions and so on, we have to do this life cycle assessment. So we aim to reduce the CO2 emission now, but we don't have now metrics because we didn't have this program now. We will have with our partners.
So the LCA is what determines this, but I think that would be a very relevant benchmarking to do.
Yeah, sure.
Thank you.
Thank you.
So what are you filing for patent? Are you patenting the process of using recycled cobalt, lithium and cobalt?
Yes, like we will, in case of we normally now we use lithium carbonate and cobalt oxide or cobalt carbonate. We would like to use recovered precious metals as an alternative for these raw materials. We already applied, so now it's pending.
Good luck, team.
Thank you.
Any final thought?
Yeah, just a question. So the weakness you mentioned. So how is your access to raw materials? Because I'm sure you're not the only one that wants to use, raw materials as in used batteries. Isn't that a challenge?
This is a challenge if we were a battery company, but since we're not a battery company, the battery companies needs to have the metal, like recovered metal from the black mass. But in our process, we can use alloy or even the ultimate waste, which they cannot be further processed. And we already did this in the proof of concept. So the challenge will not be so high as a battery along the battery companies. So the process doesn't have to be reaching lithium metal or cobalt metal. The process can stop in the lithium and cobalt oxide step, and we can buy that, or we can buy the ultimate waste, because the impurities can be tolerated within our production.
Very interesting. Thanks.
You're welcome.
Thank you so much, team.
Thank you.
We're really looking forward to seeing your project and your progress